Hi everybody, solving paper 2, June 23, paper 2R. Velocity is measured in meter per second, power in watts, moment, Newton, meter. Remember, moment is force times perpendicular distance from pivot, so its unit is a unit of force, which is Newton, times a unit of distance, which is meter, and certainly acceleration is meter per second squared. Difference between scalar and vector. Scalar has magnitude or value, and the vector has magnitude and direction. Example of scalar quantity: energy, mass. Natural gas can produce electricity. Energy store that decreases when gas is burned is chemical energy store. Burning gas or water waves can produce electricity. State advantage and disadvantage. For natural gas, advantage is reliable source or can produce high amount of electricity or can meet the demand. Disadvantage: produces CO2 and non-renewable or cannot be replaced. For waves, advantage is renewable and green technology. Disadvantage: less electricity produced or less reliable, and it is weather dependent. Here is a sponge pad that is rubbed against a car for cleaning. Some of this car is metal and some is plastic. Metal parts are earthed. Explain why pad becomes charged when rubbing the plastic and not the metal. Because when rubbing plastic, electrons transfer from plastic to sponge, but for metal, electrons goes to earth as it is earthed, so it they don't transfer to pad. Pad is held near metal post that is connected to ground. Pad discharges with a small spark through air. Sponge pad stores 5 millijoule of energy in electrostatic store. Voltage between sponge pad and metal post is 6000 volt. Calculate charge transferred by spark. So voltage or potential difference is equal to energy over Q, because its definition is energy required to transfer charge across a circuit. This is the EMF, but energy needed to transfer a charge through a part of circuit is the potential difference. So we can imagine that the spark through air is like a part of circuit, and we can use this equation, rearrange and substitute, and take care that 5 millijoule milli should be replaced by 10 to minus 3. This is to obtain the final result in coulomb. Or you can use B equals IV. Here is B is replaced by energy over time, and the I is replaced by Q over time. If for the same time energy make a charge transfer under certain voltage, so we can say that E equals QV. This is the same equation like this, and again substitution would give the same answer. Small spark between bed and metal boss demonstrates sponge bed is charged. Describe different experiment to demonstrate sponge bed is charged. You may draw a diagram to support your answer. We can approach the bed to an insulator like a piece of paper or a piece of plastic, okay, and there should be an attraction because as the sponge bed is charged negatively, and for the plastic it is neutral, so it is less negative than the bed. We can represent it as positively charged, so there should be an attraction between both. Dummy used in safety test of a car before collision. Dummy in car is traveling at velocity 14 meters per second. Dummy has momentum of 1100 kilogram meter per second. State formula for momentum, mass, and velocity. B equals m times v. Show mass of dummy is approximately 80 kilogram. We will substitute and write the result to one significant figure. Dummy is brought to rest during collision by means of a force of 15 kilonewton. Calculate time for dummy to rest. So we know that force equals change in momentum over change in time. So change in time is equal to change momentum over force. Its momentum is 1100, and when it rests, velocity equals 0, so momentum mass times the velocity would be 0. This is the difference in B. And for force that makes this difference, it was 15 kilonewton, so it is 15 times 10 to 3, because we want the final answer in second. Substitute and calculate, it will be 0.073 second. Car being tested is fitted with airbags using a diagonal momentum. Explain how airbag reduce the force. It increase time of collision, so decrease the force, because force is equal to delta B or delta mv over delta t. So as delta t increase, force decrease, and hence arm for dummy or for the potential driver will decrease. Define specific heat energy needed to increase the temperature of 1 kilogram of metal by 1 degree Celsius. Here is the solid steric acid, which is wax, being heated in boiling tube using water bath. Mass of wax is 58 gram. Temperature increased from 21 to 37. To make this increase, additional 3,500 joule of energy needed to be transferred electrically to water bath. Use this data to show that heat capacity of steric acid is 4 joule per gram degree centigrade. So Q equals mc delta T. So C equals Q over m delta T. Q is 3,500 joule. M is 58 times 10 to the power 3 to convert it to kilogram. And we converted it to kilogram because we have here the energy in joule times delta T, which is the difference between 37 and 21. After calculation, we will get this answer, and writing it in one significant figure format, it will be 4,000 joule. per kilogram degree centigrade, but he asked to prove that C is 4 joule per gram degree centigrade. So we should convert this to joule per gram degree centigrade. How we can do that? We should know that the kilogram is in denominator, so we can remove it and write gram multiplied by 1000. This would be eliminated with these 3 zeros, and we get the answer. True value of its capacity is 2.3 joule per gram degree centigrade. Give a reason for difference between value in I and the true value. So we have here a value that is higher than this, and this is because some energy is lost to surrounding, like the water, to increase temperature of water, which will then increase the temperature of citric acid, and to the air. You can say also the wall of container or wall of tube. So although citric acid only needs 2.3 joule per gram to increase its temperature 1 degree centigrade, it needed in reality 4 because of the loss. Here is a magnetic field around the section and explain why the field is shown like this. So we can use the right hand grip rule, and we will find that there is a current that goes to right in the wire. For electromagnet like that, student investigates how the change in current will cause the load to drop off. Switch on electromagnet at its maximum current, place a load of 100 gram, so it is held above the floor by electromagnet, slowly reduce current until load fall. Record the current at which load fall, record the current at which same load fall 2 more times, which means that you can repeat for other 2 times. Repeat this for different masses and suggest a safety precaution. You can say that put a pad under the load so load doesn't hit the ground when it falls from the electromagnet, and keep distant from the load. If it bounces from the floor or from the bed, it doesn't hurt you. Also, keep your hands away from the electromagnet to avoid the heating effect of current. Here is the table of a result. Here is the mass that the student put approach to the electromagnet in the starting of the experiment, and when he reduces the current gradually and finds the current at which the 100 gram mass fall, he found the result 0.28 ampere. He repeated the same step for the same weight 2 times and finds the mean. And then he repeated for other masses following the same procedure. Calculate mean at 600 gram. We will add these 3 reading and divide by 3. Plot the mean current against mass. So we will label the y-axis by current ampere, and we can choose every 10 small squares to represent 0.6, because if we look here, we will find that we increase by about 0.3 each 100 gram increase, for each 100 gram increase. So we start 0.3 at 100, nearly 0.6 at 200, 0.9 at 300. So every time we increase 0.3, here is 1.2, 400, 1.5, and finally 1.8. So it is clear that the increase is 0.3 for each 100 gram. So to represent the whole range, we need to choose this scale, because we can achieve 1.8 before the end of the plotting paper. Then we should make it clear to ourselves and write this down, not to forget and not to be confused or make an error during calculation. 0.6 is represented by 10 small square, so for each small square it represents 0.06. Okay, and certainly for the x-axis we have here 100 represented in a small square, so every small square is represented by 10. So we have here 100 with 0.3, here is 100 and 0.3. To find it at the y-axis, we can divide it by the value of each small square, which is 0.06. You will find that it equals 5, so 5 small squares on the y-axis gives the value of 0.3, or intuitively we have here 0.6, so half the distance will be 0.3. So here is the first point, and at 200, which is the second point, we have almost 0.6, so we can easily put it here. For third point, it is with 0.9, so once again should be easy to plot, because from 0.6 to 1.2 it is 0.6, and half the distance will be 0.3 from 0.6, so it is 0.9, and it is clear. You can make the other points like that, and you will make a line that uh, that is equally spaced from the points. You can find here is 2 points above the line, 2 points below, and the line is at equal distance almost from these points. After that, he asks about the true or false of making a prediction by student. Student predicted that at 1 kilogram, the current at which the 1 kilogram will fall is 3 ampere. If we looked here, we ended by 600 gram, so we cannot find it from the line, but from the table we saw how for each 100 gram we have 0.3 ampere increase. So from 600 we have how many 100 gram increase? You can count with me. Here is the first one, 100 gram. Here is the second one. Here is third one. And here is the fourth one. So we have 4 100 gram increase, and for each one 0.3, so the increase should be 0.3 times 4, and this should be added to the last value we have stopped at, which is 1.8. So you can say that the results that should be predicted is 1.83 plus 0.3 times 4, which equals almost 3. So predicting a 3 ampere for 1 kilogram or 1000 gram is the right prediction. Or, which is quite complicated, but you can use it in cases which it's not easy to predict. You can find the slope of the line and you can make your equation on that form, because here is the line is hard to meet the origin, so it is below the origin by a negative part. Okay, and this part we can approximate it to be 0.6, and the slope when you calculate it by choosing any 2 points of the line, getting the y and x coordinates of it, you can find the value of the slope, and using this equation, the equation that represents the line, you can find a value of I by introducing a value of m of 1000 gram. It should be also 3. Okay, choose the simplest one. I suppose it is this method. Okay, which sound frequency can be heard by human? We know that it is from 20 to 20,000 hertz. So 30 is with us, 500, 2000, 10,000, not 10 and not 25. Here is a wave, and he asks about another wave that is quieter and lower in pitch. So quieter means amplitude is less. So I drew the wave such that its amplitude is less than the original one. And lower pitch means lower frequency. So I drew it such that when a wave finish, just half a wave of the new one. Speed of sound varies with temperature, and student finds this equation that predict the change, and he want to calculate the speed of sound at 46 degrees Celsius. We will substitute an equation, but we should take care that temperature in equation is in Kelvin, so we should add 273 and then multiply it by 0.606 and then add by 166. This is the answer. Then he demanded a calculation for wavelength when frequency is 15 kilohertz, as the temperatures that we have just calculated is beta twitch. So we'll use V equals lambda V, lambda F, and we will substitute V by 360 and F by 15,000. We can get that stars, different stars, their masses, their colors, and absolute magnitude. Star A and C appears to have same brightness. How this come? Although they have different solar masses, this is because the A is more closer than C. If we look here, we will find that A is massive than C, but it appears the same brightness. This is because A is, sorry, I mean C is more massive than A, so we should expect C to be more bright than A, but this is if both of them was at the same distance from Earth. But as A is more closer than C, we have it more brighter. Use information to explain which star is in supernova? Certainly we know that supernova is a stage in star life cycle only when this star is massive than 8 solar masses. Okay, I mean the main sequence star or stable star is its mass is greater than its solar masses. So if we look here for the column of masses, we will find that the only one which exceeds its solar masses is D. Okay, so only D can pass by a supernova stage. Okay, in addition, it has lower absolute magnitude. Okay, explain how Mencius star evolves in supernova. So we can start by explaining how main sequence with mass greater than 8 solar masses proceed in its life cycle. It is firstly a multi-layer shell surrounding a core, where in every layer there is a fusion of elements come from the previous layer. Okay, at core it can not be a fusion for element heavier than iron. Okay, so as fusion stops here in core, radiation pressure will decrease compared to gravity. Remember that at main sequence, the point that we started from in the life cycle, we have radiation pressure equals to gravity at center of core. So when fusion stopped, energy at core is not enough to do more fusion. Okay, gravity will exceed radiation pressure because radiation pressure is originally produced from fusion. So when fusion stops, gravity exceeds radiation pressure. And when gravity exceeds radiation pressure, it pulls elements from the layered shell, okay? And when it pulled it, it is it is become it become it becomes possible that fusion start once again. Okay, so fusion starts one again, and temperature of core increases again. And as temperature of core increases once again, the wall shell temperature increases. And as the wall of the shell temperature increases, it do two things. It expands and it emits red light. Okay, so it is called red super giant because red for emission, red light, and super giant for being expanded. Now, although temperature is high, there is no enough energy to proceed fusion, and radiation pressure decreases in comparison to gravity. So we start by not enough energy to make fusion for elements heavier than iron. Radiation pressure decreased compared to gravity. Gravity pulled the elements from layered shell. After this pulling, fusion occurs, increased temperature of core and temperature of shell. Red supergiant star formed, but after a while, fusion stopped and radiation pressure decreased, and gravity will make its pulling again, makes the core shrinks and collapses, and the star as an explosion. This explosion is supernova. I want here to emphasize that you should always remember that there is a dynamic process between gravity and radiation pressure. This process depends on whether there is enough energy to make a fusion or not. Okay, please don't forget this. Make it in your consideration. You can make your answer more simpler than this. You can only write that uh, a red supergiant star formed by uh, fusion that starts after being stopped. I mean, you can abbreviate this result, this answer. You are not in need to write all of this, but I make it as comprehensive as possible to uh, confirm the whole information. Astronomers have used supernovas in distant galaxies to investigate expansion of universe. Light emitted from supernova at wavelengths 7.774 times 10 to minus 7 meter was detected at Earth with a wavelength which is greater than this. Calculated speed at which a galaxy containing this supernova was moving away from the Earth. So we have here wavelengths, the original wavelengths and the measured one, and it is clear that the measured one is greater than the original one. So there is a delta lambda. This delta lambda, if divided by the original lambda, we will have a ratio that is equal to the ratio of the velocity of the galaxy to the velocity of the light, a well-known relation. We can then substitute, make our calculation and find the velocity. Here is redshift from supernova, and astronomers find that nearby galaxies had shorter wavelengths than redshifted light detected from galaxies further away. Explain how this discovery supports Big Bang theory. So, as redshift from nearby galaxies had shorter wavelengths than those of further away galaxies, this means that nearby galaxies move with speed lower than further away galaxies. Okay, because as we know, redshift increases when velocity increases and redshift decreases as the velocity of galaxy decreases. Remember this relation? This redshift as it increases to uh, the the light, the original light. And when this ratio increases, this means that V increases in with comparison to C. So this means that nearby galaxies which has shorter redshift is moving with slow velocity than those of the further away galaxies. Okay, and this also means that the universe is expanding from a point which is the singularity. That's all. Thank you for watching and see you soon.